In addition to sensors for measuring wind and air pressure, the lander has a seismometer, a heat flow probe, and a magnetometer. While the team works to bring the probe to the surface of Mars as planned, the highly sensitive seismometer, known as a seismic experiment for the internal structure, has allowed scientists to record several earthquakes of hundreds to thousands of kilometers. NASA's InSight program is a so-called lander that studies the surface of Mars. It is the first project of its kind worldwide. Because seismic waves are affected by the materials they pass through, scientists can use them to determine the makeup of the planet's interior structure. If you enjoy our films, please give us a thumbs up, subscribe to Simple Space, and look forward to the videos that are in store for you in the future. Mars can assist the team better understand how all rocky planets, including the Earth, evolved in the beginning. What is NASA InSight? InSight is a mission of the NASA Discovery program that aims to study the deep interior of Mars by deploying a single geophysical lander. However, it is more than just a Mars mission. It is a terrestrial planetary researcher that is using advanced geophysical instruments to better understand the processes that shape the rocky planets of the inner solar system, including the Earth, more than 4 billion years ago. InSight explores Mars' deep interior to find the events that led to the genesis of terrestrial planets and measure the planets crucial. The staff behind NASA's InSight lander, which landed on the surface of Mars in November 2018, has released the data. These new measurements reveal the complexity of the planet from its atmosphere to the deep underground. These are some of the most intriguing findings of the mission. Functions, seismology, temperature, and other precision tracking InSight attempts to answer one of the most fundamental questions of science: how did the terrestrial planets form deep below its surface? A more thorough explanation of the findings made by the NASA InSight lander thus far on Mars can be found below. Mars is trembling more often than anticipated, but it's also happening more readily. The lander has so far detected around 500 minor seismic signals or earthquakes, with the strongest one measuring 4.0 magnitude. InSight's primary objective is to quantify Martian earthquakes, which could be brought on by subterranean seismic activity or anything striking the planet's surface thus far. 2 of the quakes happened close to an area called Cerberus Fossae, where the fractured ground indicates volcanic activity over the last 10 million years. This seismic activity may be due to the remnants of this volcanic activity, but InSight has not yet found any of the really strong quakes. More than 30 relatively large Martian earthquakes with a magnitude between 3 and 4 have been detected. These earthquakes occurred deeper underground than most other earthquakes, so even though they were by no means small, they would likely be barely noticeable if they were to occur on the planet's surface. Compared to the minor earthquakes that NASA predicted, the larger ones appear to occur less frequently at this period. Since then, the lander has detected additional small Mars earthquakes that were not included in this data release. These earthquakes are likely distributed throughout the planet and have different mechanisms. At the moment, NASA has a lot of data that they have not yet been able to assign or evaluate in their efforts to understand Mars and why there are so many quakes. The remaining 250 quakes that InSight discovered were relatively small, making it more difficult to pinpoint exactly where they occurred and what had caused them. The first seismic event was recorded months after InSight landed in November 2018. By the end of 2019, The lander had detected about 2 seismic signals per day, suggesting that InSight had landed at a particularly quiet time. In contrast to Earth, Mars does not have tectonic plates, but it does have volcanically active regions that can produce earthquakes. Since this is only the planet's youngest tectonic feature, it is not surprising that scientists have found seismic activity and indications of volcanic activity in the area and on Mars. Old floods. There formed channels that are nearly 1,300 kilometers long. Over the past 10 million years, lava flows have seeped into these channels, and some of these young lava flows exhibit signs of having been caused by small quakes. Because the structure and hydration of the ground affect how seismic waves travel. Through it, earthquakes can reveal details about the water distribution on Mars. It seems that minerals and water are present in the topmost crustal layers. If scientists discover stronger Martian earthquakes from the deep, they should provide more information about where we can locate water, because the crust is wetter than the moon, but drier than the Earth. InSight is outfitted with a magnetometer, the first device on the surface of Mars to detect magnetic signals. Strangely strong magnetic fields that existed billions of years ago on Mars have vanished, but they have left behind ghosts and magnetized old rocks that are now between 61 meters and several kilometers below the planet. Although this was likely the case billions of years ago, Mars does not have a steady magnetic field like Earth does. Instead, it has tiny ranges of magnetic fields brought on by rocks that have remained magnetized throughout millennia. A stable field that is roughly 10 times stronger than what satellite observations predicted indicates that there are magnetized rocks at the InSight landing site. These rocks are most likely deep underground, and their ancient magnetization provides information about the history of the Mars depths. Some of these fields have been measured by satellites, but InSight has the first magnetometer ever placed on the surface of Mars. They must have stayed relatively cool because they were magnetized billions of years ago. The rocks from the lander that have been recorded are too old to have been magnetized, so the current magnetism is much older and has a different cause. If they had been heated above a few hundred degrees Celsius, this magnetization would have been extinguished. InSight combines the data with what it knows from seismology and geology to understand the magnetized layers. Under InSight, how strong or deep would they have to be to detect this field? In addition, scientists are fascinated by how these signals change over time. The measurements vary according to day and night. They also tend to pulsate around midnight. Theories are still being put forward about what causes such changes, but one possibility is that they are related to the solar wind interacting with the Martian atmosphere. Dust. The surface of Mars is covered with more dust devils than previously thought. So far, InSight has detected more than 10,000 spinning vortices that pass through its pressure sensors, yet it has not taken a single image of a dust storm, which is surprising. This may be because the eddies are simply not strong enough to transport much dust. Wind. InSight measures wind speed, wind direction, and air pressure almost continuously and provides more data than previous landed missions. Thousands of passing whirlwinds, often referred to as dust storms, have been observed by the spacecraft's fragment sensors when they gather sand and become apparent. There are more whirlwinds at this location than anywhere else on Mars where fracture sensors have been installed. The lander itself has 2 radios, and whirlwinds and dust storms are ideal for subsurface seismic research. This X-band radio, sometimes called the rotation and inner structure experiment, records and measures seismic activity concurrently with one sending data on a regular basis. Increase can ultimately reveal details about the core's composition. Many scientists wonder if the core is solid or liquid, since a liquid core would generate more seismic signals and earthquakes than a solid core. Scientists will have a far greater understanding of the scope and velocity of the planet's seismic activity if they study the entire Mars year, which is equivalent to 2 Earth years. These initial data are just the beginning. Although the entire mission is still in its early stages and at the very beginning, science hopes that more data and evaluations will be conducted in the near future that can provide us with some insight into seismic activity. To date, the InSight lander mission has paid off, giving NASA useful information about how and where seismic activity and dust storms are occurring.